Hello guys and welcome. I hope that you're well. My name is I play 4K, AK I play 8K, AK I play 16K or UHD King. During this video, I'm going to show you Dota 2 PC game running in 16K resolution, 16K video resolution, or 133 megapixels rendered in real time with the help of native 8K resolution screen plus Nvidia DSR technology. Okay, Nvidia driver was modified as well as Nvidia shadow player was modified. I'm recording this video today in 8K resolution, so please go ahead and watch this video on 8K resolution native screen. Go ahead and switch in your YouTube player to 4320p or to 8K resolution for the maximum possible visuals. Okay, let me show you the preset, but pretty much my desktop is set to 16K resolution, which is 15,360 pixels by 8,640 pixels. Okay, it's running, as you can see, window borderless windowed mode. Even if it's set to full screen, somehow it's forced to do that. That's why I'm going to go ahead and do it. So if you're going to benchmark it in the future with a different hardware, go ahead and follow this rule. I'm going to show you maximum possible preset without the anti-aliasing, then I'm going to show you maximum possible preset with the anti-aliasing, then I'm going to disable every single possible preset, and I'm going to show you all kind of different presets during this video. So this video is not going to be as fast as possible, but this video will be very informative video for those folks that are Dota 2 PC game fans or PC hardware enthusiasts. It's a great video to watch, or for those folks that looking to find out how much it takes to render 16K video resolution in real time in today's games. And Dota 2 PC game is a very popular game. So let's go ahead and get going. So this is how we're gonna start without the anti-aliasing. Game screen render quality at 100%. This is very crucial and very important to have. Okay. So pretty much during this video I'm going to introduce you to the hardware that I'm using, but pretty much it's going to be Nvidia Titan RTX video card and Intel Core i9 9900K overclock at 5300 MHz per each core or 5.3 GHz per each core, but only 6 cores, 6 threads, physical cores. Hyper-threading technology is disabled and 2 physical cores is disabled to be able to keep 5.3 GHz stable as possible. And today I'm running 52 multiplier on my AVX2 instruction frequency, which is 5.2 GHz per each core on AVX2. Okay, so what I'm going to do, we're going to watch today the grand final for about $34 million. It's going to be, let me show it to you. So I click watch, and then I went and I click watch over here. Scroll it down to tournaments, click tournaments, and then I scroll down all the way till the international 2018. The prize pool $34 million, as you can see. I'm gonna click on that, and it's going to be OG versus Team Liquid game. I'm gonna click on that on the first one, and then it's going to be 4 games. I'm going to go ahead and select the game number 4 right here. Click watch on that, and this is the game that I'm always using when I'm benchmarking the Dota 2 PC game on different hardware. Keep that in mind. We're going to watch the English spectator and jump to game. As again, during this video I'm going to go to all kind of different presets, so this video is not going to be as fast as possible, and I will try to provide you as much as possible experience as an owner of 2 RTX 2080 Ti video cards, an SLI through the NVLink, and 2 Titan RTX video cards and SLI through the NVLink that I'm using today. But today is only one Titan RTX video card is installed on this system, keep that in mind, only one to avoid any hot pocket. If Dota 2 PC game supports SLI through the NVLink, when we are talking the Turing GPU architecture, such as Titan RTX video card, 2 of them in SLI through the NVLink, or RTX 2080 Ti through the NVLink, I'm going to go ahead and demonstrate it to you, but pretty much that's about it, guys. So as you can see, we are above 25 frames per second. Keep in mind that I'm recording today this video with Nvidia Shadow Play. It's recorded in 8K resolution as again, so go ahead and switch to 4320p in your YouTube player. or to 8K resolution for the maximum possible visuals to pretty much understand and receive the same experience or close to the experience that I'm receiving. It's going to be a little bit compressed throughout the YouTube video compressor. Keep that in mind. But pretty much we're above 25 FPS, sometimes to 25 FPS. Latency delay, as you can see at the right top corner by the FPS in ms, which is milliseconds, and FPS pretty much frames per second. So frames per second we want to keep as high as possible. Comfortable gameplay starts above 30 FPS, and latency delay we want to keep as low as possible, milliseconds delay. So every single frame is rendered. This is how much it takes in terms of the milliseconds. Pretty much is communication and latency delay between the hardware and software. Hardware such as CPU, system RAM, GPU, video RAM, and software such as Windows 10 operating system and DirectX 11 API in our particular case in Dota 2 PC game. So it's moving to even 21 FPS. As you can see, Titan RTX is already warm up, so it's not the cold boot, and pretty much this is about the same results what you are going to receive on the best possible scenario, because today I'm using the liquid metal thermal compound paste on my GPU. Keep that in mind. But the same air cooler design by Nvidia dual fan design on it, and nothing else is changed. With the hybrid water cooler you can receive maybe 2 more FPS, but you're going to invest 120 150 United States dollars at least if you're going to do that. Water cooler is not necessary for Titan RTX or for RTX 2080 Ti video card, especially if your RTX 2080 Ti video card is not reference edition. If it's just going to be not the founders edition, if it's going to be with triple fan design, you're going to be Gucci. But a hybrid water cooler is a great idea on the first video card closest to the GPU when you're running 2 Titan RTX and SLI through the NVLink, or 2 RTX 2080 Ti video cards and SLI through the NVLink. Okay, hopefully guys this makes sense. By the way, for the 16K resolution videos and gameplays, go ahead and check out 15360x8640.com. It's one of my domain names by UHD King. It's going to be dedicated to 16K video resolution and 16K gaming, 16K gameplays. Go ahead and check it out, or just visit uhdking.com. So pretty much self-explanatory. We saw the FPS. Titan was warmed up and we saw everything that we need to see. Let me go back, and I'm going to real quick go ahead and switch the preset, and we're going to test it again real quick. So let me go ahead and enable the anti-aliasing. We're going to see how much the anti-aliasing method in Dota 2 PC game reflects on our Turing GPU architecture, such as flagship Titan RTX video card from the December 2018, because the RTX 2080 Ti was released in August 2018 and Titan RTX was released in December 2018, but I got it in 2019. Keep that in mind. So every single possible preset set to the maximum quality, as well as game screen render quality 100%. This is very important, very crucial. Anti-aliasing is on. I'm going to go ahead and switch just in case for those who doesn't believe me that my desktop resolution is set 16K resolution, but I'm going to demonstrate it to you guys in the end of this video when I'm going to show you CPU Z, IDA 64 benchmark, and we're going to talk more about my hardware within the depth and details. I'm going to go ahead and click apply here, and let's go ahead and watch it again. So we're going to go ahead and watch it again. Gonna click like that, and game number oops, sorry about that. Gonna click like that, and game number 4 is again same benchmark that I'm testing constantly. But keep in mind that I'm going to record a lot of grand finals in 16K resolution in Dota 2 PC game will be available over the UHDking.com that you don't want to miss. It's going to be a great videos if you're Dota 2 PC gamer or Dota 2 fan. If you would like to watch a great finals, great videos, as well as a lot of videos Counter-Strike Global Offensive PC game in 16K resolution, grand finals will be available over the UHDking.com. And also as bonus, Quake 2, Quake 3 grand finals will be also available in Glory 16K video resolution, guys, that you don't want to miss. 16K gameplays, 16K gaming, and yeah, 16K resolution, 16K UHD, guys. Beautiful, beautiful video. Just for, if you're a fan, guys, this is the maximum possible visuals possible. And as you can see, Titan RTX is not catching up. It's not playable with comfort status, but at least playable, at least benchable. Not playable status, but benchable status. So we can bench it and we can compare with the future technologies in the future. So this is the point of this video, right? And most likely we're going to compare it over the UHDking.com, or you can come back to this video and compare it versus your system, but go ahead and apply my rules. Okay, I'm going to upload this demo file for you, so you can use this demo file and test it for yourself as well. It's going to be available in the video description or in the video comments for you to download. Keep that in mind. As you can see, we lowered our FPS by about 3 FPS. So anti-aliasing method in Dota 2 PC game is not that hardcore on the Titan RTX video card Turing GPU architecture by Nvidia, technology by Nvidia from 2018. So pretty much 16K resolution in Dota PC game was available since 2018, something not achievable by AMD GPUs. Keep that in mind. And this was available for the regular users since 2018, recorded by UHD King since 2020, and on the Titan RTX video card, but it was on my Xeon E5 2697 V2 workstation, which is the server workstation with the 24 threads, 24 logical processors. But this is the gaming PC, and this is very crucial because this gaming PC is pretty much performing the same performance almost in games that 12900K running stock. Keep that in mind, because this gaming PC is running 5.3 gigahertz on the external frequency with 53 multipliers again, and it's chilling down at 52 multiplier of the AVX2 instruction frequency, which is 5.2 gigahertz, and it's per each core. It's absolutely amazing, guys, and absolutely fast. So lowering to 20 FPS, so pretty much not playable but watchable the demos and benchable if you would like to bench it. Alright, let's go ahead and pretty much change the video preset. Let's go ahead and do that real quick. And shut down the anti-aliasing. And now what I'm going to do, I'm just going to, without the anti-aliasing, every single feature is available, including the parallax, normal maps, ambient occlusion. Actually, let me turn down the ambient occlusion. What I find out, Turing GPU architecture cannot handle ambient occlusion as fast as possible in PC games yet for this particular Nvidia GPU architecture. But let's go ahead and have a look, guys. Hopefully Ampere will, on the RTX 3000 series video cards, handle this issue. But let's go ahead and see, like, without the anti-aliasing, but without the ambient occlusion, everything at maximum possible settings. Smash apply button. We're going to go ahead and play it again. As again, same thing. OG versus Team Liquid. We're going to go ahead and watch game number 4. Go ahead and do it again. Right here, click on watch. And select the English commentator and jump into the game. Here we go. As usually with testing. And this is kind of right now when models 3D meshes with all the details in terms of the maximum amount of the 3D polygons on the screen rendered. Also can be used as a benchmark. That's why I'm showing like that, and then I'm going to show you the gameplay. So you can use some parts as a benchmark, and this is exactly what I'm going to do in the future throughout my videos. As again, guys, I'm experienced graphics designer, 3D artist, software developer, game developer, and IT specialist and professional, like system engineer. So a lot of information, a hardware enthusiast, overclocker. So a lot of information I'm going to share with you throughout my videos over the UHDking.com that you don't want to miss. And pretty much I'm going to explain a lot of knowledge in just little short videos for you. And hopefully, guys, you're going to build better computers, and it's going to help you in your information technology field, whatever you're doing. If you're doing the software development, game development, graphics design, 3D, if you're 3D animator or something, you're going to gain some some knowledge throughout my videos. And please go ahead and smash that like button. A lot of time, money, energy is invested. And yeah, support me, guys. Support me as much as you can. And watch my sponsors. I'm going to collect those pennies and invest back into you, and we're going to go ahead and continue my computer science experiment over the YouTube as UHDking.com, and hopefully together we're going to merge into the iOS application and game development when we're going to be on both. You're going to be as consumer and I'm going to be as developer, close relationship, as well as we're going to develop games together over the hdking.com. Alright, this is good, my final goal for those people who doesn't understand, but and throughout this type of approaches to share as much valuable information as possible with you guys, and this is exactly what I'm doing. But as you can see, Dota 2 PC game is ready pretty much for 16K resolution. As again, it depends what kind of preset and what kind of hardware you're having, but in 2022 most likely it's ready, especially if you're having the RTX 3090 Ti video card, because your FPS on a single video card will be at least or as minimum double as I'm receiving right now. And for the single video card in 16K resolution, double FPS that I'm receiving right now will be like at least 50 FPS. It's going to be a comfortable gameplay. At least it's going to be a comfortable status of the gameplay, and it's going to be playable status, not only the benchable status. RTX 3090 will be a little bit slower, but still will be around 50 FPS. Okay, so pretty much if Dota 2 PC game as again supports SLI, then FPS will be 1.9 times if it's going to be utilized just like it is right now, because right now as you can see we have 99% on our GPU utilization, and we want to keep our GPU utilization as high as possible and CPU utilization as low as possible, because if I'm going to reach CPU utilization above 90% or 90%, this is a clear signal for us that it requires 2 more cores to be comfortable. And if I'm not going to add 2 more cores on my CPU, I'm going to bottlenecking the FPS and bottlenecking my gameplay by the lower FPS. Hopefully guys this makes sense, but GPU utilization we want to keep as high as possible, 99-100%. This is amazing GPU utilization, because we would like on GPU utilization to utilize as much CUDA cores provided on this Nvidia GPUs as possible. Okay, we don't want to make anything idle, because we would like to utilize it to boost up in terms of our FPS. Hopefully this makes sense. The RAM utilization is again maximum possible, 24,684 I believe, but it will never reach even 24,000 megabytes. It's going to offload a lot of data from the video RAM into the system RAM, as again VRAM stands for the video RAM, which is GDR6 384-bit, and we are talking RTX 2080 Ti video card, which pretty much the same thing as Titan RTX but 10% slower. It's featuring 11 gigabytes of the GDR6 Samsung's the same memory, but 352-bit BOS, while on Titan RTX it's featuring GDR6 at 384-bit BOS, and it's reflecting in terms of the bandwidth. So RTX 2080 Ti is capable to transfer 620 gigabytes per second as stock, and Titan RTX as stock is capable to transfer 679 gigabytes per second. Okay, so when we are talking 16K resolution, it means a lot of data pushed, and we would like to have that bandwidth as wide as possible, means as much as we can push as possible. So Titan RTX results is going to also theoretically take an advantage here, but we are going to find out by comparing some videos in Dota 2 in 16K resolution over the UHDking.com. So go ahead and check it out, guys. As again, smash that like button. A lot of time, money, energy is invested, and I'm going so in depth. So for the PC hardware enthusiasts, for the particular game fans, as you can see, and doing it as much as possible, guys. So investing a lot of time, money, energy, and looking for your return, guys, so we can progress together. Okay, so as you can see, above 25 FPS. So ambient occlusion is actually stressing a lot on the Turing GPU architecture, more sometimes even in some particular games more than anti-aliasing methods. Okay, so Turing GPU architecture pretty much handles anti-aliasing That's pretty easy, no matter what kind of game engines we're talking. But where we're talking ambient occlusion, it's not that easy for the Turing GPU architecture yet. Hopefully, Ampere GPU architecture will fix that. But pretty much, what is the ambient occlusion? Ambient occlusion is like a Photoshop inner shadow. So around every single edge, it's creating additional shadows, a gradient between the dark and lighter spots, between the colors, okay, the textures on that particular model, and it's creating an extra kind of shadows for you, inner shadows, and it's creating an extra realism for you that the object is under the real light scenario. Hopefully, guys, this makes sense. Let me go ahead and switch now the preset and reload the demo. So now what we're gonna do, we're going to go ahead and use under the video preset. We're going to turn down every single feature and test it like that. Turn down every single feature. Test it without every single feature, but still kind of with the high texture quality, effect quality at high, and shadow quality at ultra, and game screen render quality at 100%. We're going to apply the settings, we're going to test it like that, and then we're going to turn up all the settings except the anti-aliasing, and we're going to start playing with the qualities, texture quality, effect quality, and shadow quality. So pretty much I'm going to handle all kind of visual presets, so go ahead and smash that like button for that extra information. So apply multiple times, we're set to go. Let's go ahead and click view. As again, Team Liquid, 5 games. We're gonna watch the game number 4. 5th game is unavailable to watch, unfortunately. As again, over the UHDking.com, I'm going to provide a lot of Dota 2 PC game replays, CSGO PC game replays, Quake 2, Quake 3 PC game replays that you don't want to miss. It's going to be grand finals, interesting videos, especially if you're fan into those games, PC games. And as again, guys, based on this video, I can tell that PC gaming will be dead in 2025. If not, then in 2027, console gaming and PC gaming is dead, and everybody will be moving to mobile gaming experience, including the AR on those mobile gaming experience devices. Most of it will be Apple devices, but also the Android devices will be on another level as well when everybody will be deciding between Android and Apple instead of PC or console. It's coming, guys, just like I predicted in 2018 before the metaverse. I predicted the metaverse and AR experience before the M1 chip. And this is what I stated, guys. I stated that even the A chip by Apple in 2025, like A18, I stated during that time in 2018, will be powerful enough to run the games in 4K resolution and provide it will that type of chip, A18, will provide same type of visual just like maximum capable gaming PCs today in 2022, believe me. And it's going to happen in 2025. By Apple mobile devices, it's going to consume just a hair of electricity, and it's not going to consume electricity on your money, on your electric bill, and it's going to be convenient in your pocket, and it's just going to dominate the PC gaming and console gaming. This is what I see, guys, after I saw and analyzed the 16K resolution, 16K video resolution, 16K gaming, even back in 2016 on my 4 Titan X Maxwell GPU architecture. Unfortunately, Titan X Maxwell GPU architecture and Titan X Pascal GPU architecture featured only 12 GB of VRAM, and as you can see that 24 GB of VRAM is necessary if we are talking about 8K resolution comfortably, especially when we're talking 16K resolution in classic games. 24 GB of VRAM is necessary. Otherwise, a lot of data will be offloaded from the video RAM into the system RAM, and system RAM today I'm using 3300 MHz CL11 timing. Yes, it's pretty aggressive timing, but 3300 MHz that's producing 50 gigabytes per second maximum bandwidth output. 50 gigabytes, and today just through my video RAM overclock, which is additional by 2000 megahertz, So VRAM went from 14,000 megahertz to 16,000 megahertz. We achieved 100 gigabytes per second data transfer bandwidth just from the overclock. So 2 times more than my DDR4 on my system RAM is capable. Okay, that means that when I'm going to upload some data from VRAM into the system RAM and then call it again, the FPS will be pretty low, and we're going to be pretty much receiving the very high latency delay, which will be very slow, very stuttering, and the very low FPS. Hopefully, guys, this makes sense. And thanks to the Nvidia drivers and Microsoft operating system, it learned how to offload some data from the video RAM into the system RAM before the game is crashing under the 3D rendering API surfaces such as DirectX 11 API, Vulkan API, OpenGL API. This is what I thought, guys, throughout my experience and investigations and analyzation of the 3D rendering in real time, in the resolutions, 4K resolution, 8K resolution, and 16K resolution throughout 2016 all the way till 2022. And this is type of information that I shared with you throughout my videos. Hopefully, guys, you learn with me, you grow with me, and don't forget to smash that like button. Again, I'm providing you the value right here. There is no copycats, at least respect me for that. Okay, guys, so what I'm gonna do, so we just watched at that type of preset. Now we're going to go ahead and switch the preset real quick, and I'm going to enable every single feature just like I promised you, and we're going to start playing with the preset down below. VSync will be off because we're trying to test maximum possible FPS, of course. Everybody understand? So anti-aliasing will be off, everything will be maxed out. So I'm going to start with the effect quality. I'm going to put the effect quality low and shadow quality medium, but we're still going to have some shadows. We still want to have a beautiful picture because we're running 16K resolution. What's the point otherwise? I'm going to test like that, and then I'm going to turn down the texture quality. Actually, let me turn down everything right now at low. Let me go ahead and do it at one take, just like that. Apply, and let's go ahead and load it up again. Need to go ahead and load it up. So pretty much lowest possible preset possible with all kind of features enabled, including the normal maps, parallax, ambient occlusion is enabled, but no anti-aliasing. Can we achieve a playable FPS in 16K resolution? I'm just curious. As you can see, GPU utilization went 100%, which is amazing. This is exactly what we want. And our CPU utilization never even saw 50%. That means that 6 cores, 6 threads is more than enough in this particular game, which is Dota2 PC game, at 16K resolution. If you're going to add more cores, you're not going to boost up your FPS. Even if theoretically you should, but it's not going to work like that. This is how PC gaming in 2022 works in terms of the multi-core utilization before the multi-cores throughout the 3D printing process. Okay, this before the 3D multi-core or 3D cores technology by Intel or AMD. And this is how it works. By adding multiple cores, you're not going to boost up the FPS, but only going to create higher latency delay. This is the only thing what you're going to do. 30 FPS, it's playable status though, but not comfortable. But for a particular game, I would say we can say it may be comfortable. Not for the competitive, but you can play it online like that at 30 FPS because it looks like from the top, almost like real-time strategy, and this type of games at 30 FPS are kind of playable. At least for veterans, for the classic gamers, keep that in mind. So 16 gigabytes of VRAM usage, almost 15,600 megabytes, as you can see, and system RAM utilization went from 9,000 gigabytes, which should be 9,000 megabytes, to almost 12,000 megabytes. That means that there is a possibility we're already offloading some data from the VRAM into the system RAM. There is a possibility of that, okay? Because usually this game in 16K resolution utilizing below 10,000 megabytes. Just want to let you know. And when I loaded this game, most likely this is what you saw, was that type of utilization. But I already loaded, it was everything warmed. The GPU was warmed. I tested the game just to make sure that everything is running correctly before I start the the record of this video. Before I started the record of this video. Yep. So pretty much, as you can see, a lot of characters on the screen, still crazy FPS, way above 25 FPS, and just because I'm recording with Nvidia Shadowplay without the recording added 3 FPS to the FPS counter, because I'm recording with the software on the same computer, utilizing some resources, keep that in mind, and recording in 8K resolution, which is amazing. Alright guys, so 12 gigabytes, as you can see, 16 gigabytes of the VRAM utilization and system RAM, almost 12 gigabytes. So pretty much 16 gigabytes of system RAM will be more than enough in PC games, in light PC games. Maybe something like in Battlefield or newer Call of Duty, you will be needing like 18, 20 gigabytes or 32 gigabytes will be good enough on the system RAM. But 24 gigabytes, guys, of the video RAM is more than enough in any games, even at 8K resolution. But if you are talking about 8K resolution, you want to have at least 24 gigabytes to start, but comfortable without offloading any data from the video RAM into the system RAM, even by the driver mistake. You're looking to have 48 gigabytes of VRAM, so it's going to be a comfortable gameplay in 16K resolution in the PC games that was released in like 2016, 2018, all the way till 2018. If we're talking 24 gigabytes. If we're talking PC games that was released 2018 2022 in 16K resolution, you're looking to have 48 gigabytes of VRAM at least, and you're looking to have the GPU computing performance power as 2 RTX 3090 Ti video cards, which will be a little bit faster than RTX 4090 video card. An RTX 4090 video card over here will show at least 3 times FPS, which will be like at least like 70 FPS average, which will be amazing. 16K resolution for a single video card. An advantage of the single video card versus the 2 video cards is that it's going to perform like that in any game, and 2 or more video cards in SLI or Crossfire is not going to perform like that at any game. It's only going to perform like that if that game supports multiple video cards through SLI technology or through the Crossfire technology. Keep that in mind. So single video card will be always better idea to have, but if you can buy used old school technology and it's still going to perform in SLI faster than or on the same level as single video card and cost less money, go ahead and execute the plan, guys. But as again, in 2022 all the way till 2023, the end of the year, the video cards pricing will be crazy, because even when Bitcoin complexity will be harder for the video cards to mine, then people will mine something else, some other crypto. Keep that in mind. So GPU drama on the market is increasing. So Titan RTX is a great video to have, but you only want to have 2 of those video cards, and you only want to play 8K resolution and above when 2 video cards utilize, when you're going to utilize heavily that 24 gigabyte of video RAM frame buffer. Otherwise, get yourself one RTX 2080 Ti video card in anything below 8K resolution, and do not get 2 RTX 2080 Ti video cards in a slide, because it's useless, because it's going to holding back by the video RAM frame buffer, which is 11 gigabyte of VRAM on each RTX 30 on each RTX 2080 Ti video card. So 2080 Ti video card in Crossfire is not a good idea, but Crossfire with 2 Titan RTXs as the last moment not the Crossfire, sorry, in SLI is a great idea. So 2 Titan RTXs in SLI is a great idea. Single RTX 2080 Ti in SLI is not a great idea, because you're going to be limited by the video RAM. Alright guys, alright, that's it, that's pretty much it. Let me real quick go and close the game. I'm going to introduce you to a computer that I was running today, but pretty much as you can see and tell, this video is self-explanatory. Everything is explained. I already was saying the Crossfire on SLI, I cannot believe it. Trust me, I know what I'm talking about. So this is the for VR Mani. This is the soundtrack, royalty free, no royalty can be claimed, all rights reserved, and for the commercial usage as well throughout this video. Alright, let me real quick show you that my desktop, as you can see, was set My desktop, as you can see guys, was set to 16K resolution, and this is under the magnifier 1200%. Look how everything is so clear. So pretty much when you are using your screen with zoom tool, this was pretty much created by and innovated by UHD King. When UHD King started using the resolution above 8K resolution, this is how I was pretty much getting on the screen. And when people are going to start using it on the desktops and on the laptops, remember, it was innovated by the UHD King. Remind them that when he was recording videos above 8K resolution. So pretty much guys, this is how it is. To keep my CPU stable, as I already told you, shut down 2 cores in the BIOS, shut down the hyper-threading technology. So I'm using the physical cores only, 6 physical cores, 6 physical threads, 5.3 gigahertz frequency per each core, or 5300 megahertz. Very fast, very absolutely amazing, like a rocket in any games. Even this is CPU from 2018, but even in 2022, compared with 12,900K, it's going to be a hair faster or a hair slower than this CPU, because this CPU is overclocked like, oh my god, it's tuned, not only overclocked to 5.3 gigahertz, but it was tuned to 5.3 gigahertz, crazy tuned for the maximum possible performance in PC games, for the maximum possible FPS. So 5300 megahertz external frequency and 5200 megahertz as AVX2 instruction frequency, amazing. So this one is shielding at 5.2 gigahertz. So performance is amazing. ASUS Maximus 11 here. Memory is again 3300 megahertz, which is 1650 times 2. CL11 1T command. Was using the cache frequency 48 multiplier, dual channel, which is 128-bit, 32 gigabytes. As you can see, memory is not easy memory. You're not gonna set like this with regular memory. Your DDR4 3200 CL14 will never even reach CL12. It's going to be unstable. But this CL11 3300 megahertz is completely stable, and this is probably the maximum possible scenario of the DDR4, the fastest possible scenario for the Intel Core i9 9900K processor, okay, at the maximum possible fastest scenarios. And I achieved that, as you can see guys, with the Corsair DDR4 5000 megahertz, which is 2500 megahertz times 2, 5000 megahertz CL18, but it was Micron chips. Micron chips is not great on the frequency, so on this particular motherboard it's not even stable at 4000 megahertz, no matter what CL you're using. Corsair told me it's only going to be stable on MSI Godlike for the Ryzen 5000 series, but I have some doubts about it. But Micron memory is great in terms of the low latency delay, and I utilize it pretty well. CL11 1T command, this is unbelievable, and this is how I use it, and this is pretty much the fastest possible scenario for this particular CPU, for this particular motherboard, which is Maximus 11 here, with this particular memory, which is Corsair DDR4 5000 megahertz. It was very various memory, very expensive, about 1000 during that time in 2020, 2018. But as you can see, it's not great for the Intel chipset, means the memory quality is not that great. It's particular designed maybe for a particular task, as again we're going to find out when I'm going to test this memory on 12900K, because that chip is supposed to run this memory easy, even if it's designed for AMD. Anyways, Titan RTX base boost, and we're running above that 8000 on the GDR6 times 2, 16,000, so 2000 megahertz additional boost, even if MS Afterburner says 1000 megahertz on the GDR6 VRAM, it's times 2, 2000. So from 14,000 megahertz we went to 16,000 megahertz, and improved in terms of our pixel fill rate, bandwidth, everything. In a second I will explain to you. Core or GPU was overclocked plus 100 megahertz additional, maximum possible scenario. And let me show you the GPU Z. As I told you, I'm going to explain to you what kind of boost in terms of the performance for free, without investing in $100 you can achieve. And this is pretty much I advise you to have. It's stable for home safe environment. So as you can see, this is our values, GPU clock boost, and etc. So via pixel fill rate 179 gigapixels, textual fill rate 528 gigatexels, and bandwidth 768 gigabytes per second. Okay, check it out. I'm going to bring it to stock. I brought it to stock, and right now immediately we're going to change the values. We lost here about 6 gigapixels per second pixel fill rate. This is based on the GPU overclock, and textual fill rate also based on a GPU overclock. Actually, textual fill rate will be based on a video RAM overclock, 509 gigatexels, and bandwidth will be based on a video RAM overclock. We lost almost 100 gigabytes per second data bandwidth, which is exactly a half double, not half, double of what our DDR4 is capable to push in terms of the bandwidth, because DDR4 is capable to push 50 gigabytes per second or 50,000 megabytes per second read, write, and copy, which is the best, by the way, for the DDR4 value in dual channel. Keep that in mind, even for 12,900K CPUs. But you're talking the latency below 44 nanoseconds, NS nanoseconds. 12,900K cannot push below 44 nanoseconds. This is how fast it is for DDR4, and I'm talking 12,900K running DDR5, guys. Okay, so latency will be unchanged no matter how many cores we're gonna add. But if I'm going to add 2 more cores, level cache, level 1 cache, level 2 cache, level 3 cache, read, write, and copy bandwidth will increase. Those gigabytes per second will increase if I'm going to add more cores. But keep in mind that 16 logical processors running 2100 gigabytes per second level 1 cache read and copy, so I'm only 200 gigabytes per second less, and I'm only using the 6 logical cores, and that one is using 16. So this is how fast the CPU today, and the fastest frequency the better in PC games. When we're talking workstation, the more cores the better, but PC games, the faster frequency and the newer technology of the CPU, which pushing more instruction per core, is the better. Keep that in mind. Alright, so pretty much, guys, I explained to you everything what you need to know. And as again, the single core performance, this is what we're looking at the CPU benchmark for those who's curious. For 5.5 times on 6 cores, this is a great score. Let me show you how the stock i9-9900K scored. So we almost 100 points above on single thread performance, and as again PC gaming, we're looking at the single thread performance. Let me show you how the 10,900K scored. By 40% we're faster. Alright, so this is very fast scenarios, guys, absolutely amazing and fast scenarios. Check it out. Let me show you how the CPU scored, and you can see we're dominating 3950X by almost 100 points. This is just unbelievable. And as again in PC gaming, by single thread performance. So this is it, guys. Let me also show you what kind of resolution I was running today. Display settings for those naysayers. So 15,360 multiplied by 8,640. Okay, 100% scale. This is very important to keep 100% scale in most of the games, especially when you can see the FPS is jumping, just to make sure that you're receiving the real native experience of 16K resolution achieved through the Nvidia DSR. But as again, it was rendering in 16K resolution, and this is exactly how much resources you will be needed in 16K resolution. And then it was downscaling. So, and when it was downscaling that 16K resolution to 8K resolution for you to watch, pretty much it was increasing the pixel density, and quality is much better than just regular 8K resolution native just render that game. Alright, so hopefully, guys, you understand. Hopefully, guys, you smash that like button already, share it with your friends, those fans of Dota 2 PC games, fans, strategists, and etc., or PC hardware enthusiasts, and check out the UHDking.com. As again, subscribe, and I will see you guys till the next time. Support my sponsors. Right now I'm putting some great videos for you to check out, and check out the 15,360 times 8,640.com, my domain name dedicated to 16K resolution videos and the true 16K resolution video. And today you just watched the true 16K resolution video through the Nvidia DSR method, which is the real 16K resolution render, and then downscale to my resolution. This is the whole process. Hopefully, guys, everything made sense, and yeah, I will see you till the next time. Have a great 2022. Till the next time.